Hello Year 10 and welcome to today's lesson. Once again we'll be continuing along with our theme of algebra, continuing to look at quadratic equations and expressions and different ways of factorising and solving those. Today we're looking at completing the square, which is useful for many different reasons, including solving quadratic equations. To start today's lesson, can you go ahead and pause this video and have a go at the do now? Okay, welcome back. When factorising a quadratic equation with no coefficient of x squared, we simply need to look at these two numbers. I want to find two numbers that multiply to give me 9 and add to give me 6. Listing of factors of 9, I can get 1 and 9. I can also get 3 and 3. 3 and 3 are the two that will add up to give me 6. Therefore, my factorisation is going to be x plus 3, x plus 3. There is an alternative way of writing this, for example, x plus 3 all squared. Remember, if you were ever asked to expand something that looks like this, you do not do this. That is wrong. All you've done there is you've squared x and you've squared 3, but that's not what this is telling you. This is telling you it's the whole bracket multiplied by itself. So you would have to write it out as x plus 3, and then use your preferred method of expanding. Okay, so if ever you are to expand something that looks like this, do not do this. You must write out the bracket twice, and then you can expand using your preferred method. Okay, I'm going to just give you the rest of the answers. Okay, and you will have noticed that for question 2, you could have also written it like this. And for question 3, you could have also written it like this. If you were struggling on question 4, you'll want to go back to lesson 4 and have a look over your notes there, and perhaps even watch the video if you're really struggling. Okay, as I said, today we will be looking at completing the square. We're actually going to do a few lessons on this week. So this is the first lesson. Please write down today's date and title, as well as that key definition. Okay, so why do we use completing the square first? I think it's an important discussion. For today, the only thing we'll be looking at is actually writing something in the completed square form. However, as we go throughout the week, you will learn how to use that to solve equations. Okay, so for this week, we will purely be looking at writing it in the completed square form and then using that to solve quadratic equations. We've looked at a few methods so far. This is a really nice one as well. But there are also other reasons we use completing the square form. If it was instead of, you're used to seeing things that look like this, and you can solve that. But if instead it was actually an equation of a curve, if we can write that into the completed square form, it tells us lots and lots of information. For example, we often write them like this. This is the completed the square form. When you take this equation and write it in this format, it gives us lots of information to do with three bullet points. Firstly, we can find out that our turning point of the graph is at -a, b, so we can take that from this equation. We can also find the line of symmetry once we've sketched it, or even just by considering it like this. And this also tells me this is a translation of the y equals x squared curve using this vector. So it has lots and lots of applications. We can use it to solve. We can also find the turning point of a quadratic graph, find the line of symmetry in a quadratic, and also consider the translations of graphs. Can you please pause the video here and write down these 4 bullet points on why we use completing the square? Okay, so I first just want to look at completing the square and how it links back to an original expression. As we progress throughout this week, I'm going to start to add a number on the end here, and we'll look at how to use that. But for today, I just want to look at ones where we don't have a number. So as you've already looked at, completing the square is taking something that looks like this and turning it into this format, where we've got x plus a number, or maybe subtract a number squared, and then plus or minus another number. To consider how we go from this step over to this step, I actually want to expand this to start with. I'm first just going to look at this first section here, x plus 4 squared. Well, that can be rewritten as x plus 4, x plus 4. If I expand this, and I'm going to use FOIL, but remember there are lots of different methods, and we do first, we get x squared, outer, we get plus 4x, inner, 4x, and last we get plus 16. Now if I combine like terms here, you'll notice that I get x squared plus 8x plus 16. So that is just this section here. But I cannot yet say that that is equal to x squared plus 8x because I've got this plus 16. That's the extra part that I've got. I need to remove that part, and that's why we have this section here. This part here creates too much. It adds on an extra number at the end, so I have to subtract that after. Now that I've done the 16, I can say that these two things are equal. So when I'm actually completing the square, what we actually do is we always have brackets with an x and squared. The number that goes in here is half the coefficient of this number here, half the coefficient of x. So in this case, it's going to be plus 4. If this was negative 8, it would be negative 4. If it was plus 10, it would be plus 5. If it was minus 20, it would be minus 10. So it's half this number here. We then subtract the number that I've written here squared. In this case, 4 squared is 16, so I subtract 16. And you can always check these. That's the great thing. Once you've written it in the completed the square form, you can always expand this part, then combine like terms and work out if you've got your original equation. So when completing the square, we halve the coefficient of x, open brackets, which look like this. This number here is, so the square is replaced by step 1. Then subtract the square squared. Okay, can you please write down these steps? And in a moment I'll go through another example, just simply following the steps to show you how we go from a general quadratic into a completed square form. Okay, so we're going to look at this one here, following those steps that I've just written down for you. So step 1 was to find half of this number here. So that is going to be positive 3. Step 2 was to open up my brackets with x at the beginning and a squared on the end, and to take this number and place it here. Step 3 is to continue with that, and then take this number here, square it, which gives me 9, subtract it from the total equation. That there is your completed square form. I am going to expand it just to check for you. X plus 3 multiplied by x plus 3, and then subtract 9. This expands to x squared plus 3x plus 9, subtract 9. I now get x squared plus 6x plus 9, and subtract 9, cancel each other out. That therefore has been correctly put into the completed square form. Please pause the video and write this down as an example, including the steps where I've double checked my answer. Okay, please have a go at this one on your own. And there is your answer. We halve the coefficient of x, and that goes in the form into the equation here. And then we square that number and subtract it. Okay, I have already mentioned that if we have a negative number, we follow the same steps, but I want to show you that here. So step 1 is to halve this number. Well, that's going to be -8, and that negative is important. Step 2 is to open up my brackets and write that number into the correct place, -8. Step 3 is to keep that there, and then I want to subtract this number squared. -8 times -8 is actually still going to be a positive number. 8 times 8 is 64, so I'm subtracting 64. If you wanted to, you could then re-expand that and check your answer. Please pause the video here and write this down as an example. And have a go at the one on the right. There is your answer. I'd like to point out here that despite the fact that it's negative here, that does not change the number on the end. It's negative in the middle, but that doesn't change this sign here. Just to show why, I want to expand this answer here for you. X minus 5, x minus 5, and then subtract 25. X times x gives me x squared. -5 times -5 is going to give me positive 25. And then get -5x, -5x, and I've still got that subtract 25 on the end. These two terms cancel each other out, and I'm left with x squared minus 10x. So just because this one has switched to a negative doesn't change this sign over here. Okay, alternatively, we could find that either there's no number written here, or that it's not a number that halves easily. Okay, this is in fact both. Technically, the number 1 is written in there. We just don't see it because in algebra, if we have one lot of something, we don't write the number in front. I've chosen to write it in here just so you can see how I'm about to solve this. Now, you're probably thinking this is quite difficult. I can't just find half of 1. Half of 1 is a decimal. Is that okay? Is that allowed? It's kind of a fraction. It's a bit of everything. You are allowed decimals and fractions in algebra. You don't see them very often. Often we'll use quite nice examples to give us nice answers. That doesn't mean that you can't have decimals or fractions in an answer. So I'm going to follow the same steps, but I'm going to choose not to use decimals. I'm going to choose to use fractions, and you're going to see why in a moment. Step 1 is to find half of this number. Well, that's going to be a half. Half of 1 is just a half. Step 2 is to write it into the brackets with that squared on the end. Step 3 is to subtract this number squared. The reason I write it as a fraction is because a half squared is just 1 squared over 2 squared, which is 1 over 4. That is a much quicker thing to do than trying to, for example, do 0.5 squared. You could do it, however you may slip up where you put the decimal, or you may get slightly the wrong answer. I would always encourage you to do it as a fraction, because when I square a fraction, it's the same as squaring the top and squaring the bottom. So I've found my square of a half, and I now want to subtract that. That there is your final answer. So I'm not going to stop you writing it as a decimal, but I strongly encourage you to write it as a fraction. Please pause the video here and write this one down as an example. And please have a go at the one on the right. Step 1 is to halve this number. I'm just going to write it as a fraction. It's 3 over 2. But it's going to be negative because I started with a negative coefficient. Step 2 is to write that into the brackets. Step 3 is to subtract that number squared. So now I'm going to subtract it. Negative 3 over 2 squared. Well, that is negative 3 squared over 2 squared, which gives me 9 over 4. I'm subtracting 9 over 4. Once again, this is a lot easier than trying to square negative 1.5. If you had a calculator, you could, but often these questions will come up in a non-calculator assessment. Okay, I haven't gone too far today because I want you to practice on these simpler completing the square questions. In tomorrow's lesson, we will make this a little bit more challenging by actually having a number on the end here and considering what impact that has. And then after that, we're going to look at what happens when we have a coefficient of x squared. So for now, For the rest of today's lesson, I want you to pause the video and have a go at these questions. Question 1, I simply want you to expand this. Make sure you combine any like terms to write it in this format. Some of them will have a plus C, some of them won't. And for question 2, I want you to write each of these in the completed square form. Some of them are going to be positive, some are going to be negative, and some might even be fractions. Okay, well done for having a go at those questions. Some of them are quite challenging. There are your answers. And we have come to the end of today's lesson. As I said, tomorrow we will be looking at slightly more complex equations and using similar methods to write them in the completed square form. Hope you have a nice day, and I'll see you in tomorrow's lesson.